Saxon Algebra 2, lesson 68. Today's lesson is about using a calculator. So the very first thing I want you to do is go make sure you have your hands on a scientific calculator. It doesn't have to be a graphing calculator. A graphing calculator looks like a Game Boy, honestly, to me anymore. It is fairly big and it's got a fairly large screen. So it's probably like a really old school Game Boy, which is all I know. We don't need a graphing calculator. A smartphone that has a calculator that you can turn landscape style and has all the buttons, that will do perfectly. So go get one right now and then come back. Okay, you're back. We're going to practice using a calculator in two specific applications. Now, let me preach that this does not change the basic rule about calculators and math. For everything else, except the very specific applications when I tell you, yes, you can use a calculator, we never use calculators in math. Calculators make your brain lazy. They make everyone's brain lazy. I never use a calculator either, unless the same time you do. Because once we switch over from pushing a pencil and thinking to pushing buttons on a calculator, our brain, well, I had a joke with one of my students who was an athlete and was always trying to get exercise, but was really in the heart of his soul, he was a couch potato and he had to kind of force himself to work out all the time. Using a calculator makes you a fat kid on a couch. It makes your brain not have to work. And then once you stop working, you just get lazier and lazier. You know what I mean? That like self-perpetuating cycle that you get into. Everybody does. I don't just mean you. So that's why we always push our brains to do the calculations in our head rather than on a calculator. There are very few calculations that are complex enough, like trig functions, right, that we can't do them in our heads. So every once in a while, we'll bump up against a type of problem where we need to use the calculator because they're more complex. In university level classes, teachers, instructors / professors do usually allow students to use calculators. And you know, that's up to them. I think that as a high school teacher, it's really important that I make sure you train your brain the right way to do it. And I can't control what happens from here on out. So, okay. So what John is going to do is first he's going to tell us how to use a calculator to do scientific notation. And he's going to give us a disgustingly ugly problem. It doesn't make me want to use a calculator. It makes me want to run and cry. I'm going to use every bit of my page and I'm going to squeeze. Okay, that is the number John wants us to multiply. And, you know, honestly, this is not unreasonable for a scientific calculation, right? If you're doing chemistry, for example, you might need to multiply something god-awful like that. But here's a very important rule. This is a hard practice to force yourself to do, but I'm going to help you remember. We always want to estimate before we calculate. That way, if our finger slips and we hit the wrong button, we'll catch it. Because that's one of the other problems with scientific notation, right? If your hand just brushes against the keypad wrong and you accidentally add a digit to your calculation, you might not even notice unless you have a pretty good idea of what you think your number should be. So that's what we're going to do. We're just going to round these numbers and do a quick little calculation to figure out where the ballpark is that we're looking for. So let's fix this first. It would be minus 4, right? And we'll move the decimal 1, 2, 3, 4 times. 10 to the 4th. Then we'll bring down 10 to the minus 8, and we'll combine that. So this ends up being, I didn't need to draw a line there, minus 4 times 10 to the negative 4, right? And then let's do this one. Let's see, we want to move the decimal 1, 2, 3, 4 times. So it's 3, rounding it down to 3, or yeah, not up to 4, times 10, we moved it what, 4 times? To the minus 4, and then we'll bring in, oh, I want to make that a dot. Well, I made it an X there. Whatever, 10 to the 15th. Now, this is what I was trying to show. We combine those, and then this becomes 3 times 10 to the 11th. And then we multiply the front numbers and add the exponents, and we get minus 12 times 10 to the 7th. Oops, this got too big, so we'll bump it one more time. And that is minus 1 times 10 to the 1st power, right? We bumped it once, and then times 10 to the 7th. So our final estimate is minus 1 times 10 to the 8. Oh my gosh, we did all that work just to do our estimate. But that's okay, because pushing buttons is fast and easy, which is why we're always so tempted to use a calculator. Look, my puffy cloud of knowledge is extending. Okay, I'm going to copy this to the top of the next page, and then we're going to talk about how to actually enter that. Ready? Minus 1. Okay. Now we're going to calculate, and the button that we're going to use, that's going to help us a lot, is this one. I'm sorry, my phone that is my calculator is also my camera, so you know, I can't show you how to do this, but I can explain it to you. So the first thing we do is we enter the number, which was what, minus 40,000.652. Remember that the way you do that is you enter the number and then you hit the plus minus key, right? To make it a minus. Then hit times, then enter the exponent, which is 4, the original exponent, oh no, it was 8, and then you'll have to use the plus minus button again. I don't know if this list is making any sense, but you'll have to hit the minus button again to turn that into an 8, and then here comes the mad genius. We use 10 to the x. What the calculator does is when you hit this button, it uses the last button you entered as the exponent, okay? So we put in the number times, then the exponent, then this button, okay? So what you should get, oh wait, that's just the first number, isn't it? And then you have to put, what I would do is I would have that answer, then I would open the parentheses, and then you have to do the very same thing with the second one. Enter the number, and this time it's 0.000324. It's positive, so you don't have to worry about the plus minus. Then you'll do times, then you'll enter the exponent, and in this case it was 15. and then you hit 10, whoops, that's a messy button. Let me write over. 10 to the x. That takes this last number you entered, puts that in as the exponent, and then multiplies it by that, right? It does the whole thing. Then you need to close the parentheses and hit equals. If the gods are with you, you will get the actual answer of minus 1.32 times 10 to the 8th. And if you compare it to our estimate, minus 1 times 10 to the 8th, you will see that is pretty darn close, isn't it? So that gives us a giant smiley face, bigger than usual, okay? If you want, what you can do is simplify one of the numbers, then write down your answer, and then simplify the other. If using the parentheses intimidates you, you can write down and do it that way. But I want you to do the calculations in the calculator as much as possible. If we're going to use the calculator, then we commit hard to the calculator. That's my feeling. Use all the functions and get used to using those parentheses too, because we have to use those a lot. Okay, we have to do one more of these beastie boys, and then we're going to switch to another use of the calculator that's much easier. This time we're dividing. 40,652 times 10 to the minus 8 over that whole big thing again. Okay, this time we're dividing them. Last time we multiplied them. I'm not gonna work out these again. I already know what they are. I have them from the other problem. I know that the first number is 4 times 10 to the minus 4, and I know that the second number was 3 times 10 to the 11th. So 4 divided by 3 is 1.3 times 10 to the this minus this, so it would be minus 15. Okay, I don't need the 3. I can call my estimate 1 times 10 to the minus 15. That's my estimate. Now I'm ready to calculate because I obeyed John's rule, estimate before you calculate, or you know what he'll do? He's up in heaven watching us. He would throw a bolt of lightning down and frighten us terribly if we did not do it the way we're supposed to. Okay, run all that through the calculator using that 10 to the x button to do your exponent. Remember what this, when you hit this key, it will take the last number you entered and use that as the value for x. Okay, so you do this, and then you do divided by, and then you open the parentheses and do the whole thing. Close the parentheses, equals. And what you will get is an actual value of 1.25. Oh, my cat's throwing up. That's cute. 1.25 times 10 to the minus 15. And that is a lovely answer. It's very close to ours, isn't it? Okay? Yay, beautiful. Oh, I forgot to finish this. 68.2. Squish it in. All right, that's doing scientific notation on a calculator. You can do it. It's not that bad, but it's kind of a pain. The second topic that we're going to do, which is, I'm going to switch to a new page. We're going to talk about powers and roots. Those are much more enjoyable on a calculator. Powers and roots. Ready? Example 68.3. We are looking for, oh boy, are you ready? This is such a crazy number. We're taking the number 50.42 and we're looking for the number that multiplies by itself 3.28 times to give us that. What? That's nutty. But our calculator can find it out for us just fine. What we want to do is we want to estimate. This is a sign that means roughly equal to or similar to or about the same, approximate. So it's a perfect sign to use in these. This is going to be about the third root of 50, right? We can round to those numbers pretty easily to that. Now, what's a third root of 50? 50 is not a perfect cube, so I don't know. So let's make a list right here of our perfect cubes. 1 cubed equals 1. 2 cubed equals 8. 3 cubed equals 27. We're getting closer. 4 cubed, 4 times 4 is 16 times 4 is 64. Okay, we've done it. We know that whatever number cubed that equals 150, it should fall in here, right? Another way of saying this that might help your brain see it better is the cube root of 1 equals 1, the cube root of 8 equals 2, the cube root of 27 equals 3, and the cube root of 64 equals 4. This is another way of saying the very same thing. This might help you compare. So we can see that our estimate for the 3.28th root of 50 is going to be based on the cube root of 50, and that would fall in between 3 and 4. Okay, that's not a plus, that's a quick little and sign. All right, beautiful. So now we're ready for our actual calculation. You will see on the calculator 3 different buttons that look like they might help us. There's one that's used specifically for cube roots, okay? There's another one that's used specific, did I say cube? I meant square. Square roots and cube roots. These buttons exist with the 2 and the 3. With these buttons, you answer the number that you want in here, the number that you're trying to find either the square or the cube root of. Then you hit this button. This button says, I'm going to take the last number you gave me and find the square or the cube root of it. All right? Now, what do we do about something like this where our root is not just a simple 2 or 3? Well, there's a special button for us where we can customize the way the root works. There's an X here and there's a Y here. Okay? So the way that works is you enter first the pig, which is equal to X, the number on the inside. Then you hit that button. Then you hit the root number, which is equal to Y in this picture. All right? So that's how the calculator does it. You enter a number, then you hit this button. It says, oh, okay, I'm going to take the last value you gave me and I'm going to put it in the pig house. Then whatever you hit next, I'm going to put in here. So then you enter that button, and then I believe you have to do an equal sign as well. Some calculators will just give you the answer. Others want you to hit equal. So you have to just figure that out. Okay? So that's how we use this custom button when we have tragic examples like this. We follow this flow to enter, and what we will get for our actual, let's see, this was our estimate, and our actual value for the 3.28th root of 50.42 is 3.304. And so, happy days, once again, our estimate turned out to be a very lovely approximation of what we're doing. Make sense? So now we've learned how to use these buttons, and we have one more. Example 68.4. And wouldn't you know, I don't know why John feels that he is allowed to do this, but he does this A and B thing. So first we have to do A. It's 9.26 to the 4.58 power. All right. Well, let's estimate. What we're going to do is we're going to say that's kind of like raising 10 to either the 4th power or the 5th power. 10s are easy to calculate, so we'll try both. So we think our estimate is going to be somewhere between 10,000 and 100,000. All right? Now, how do we actually calculate this? Well, just like in our last set of buttons, there's one set up so that we can square numbers, and there's another one set up so we can easily cube them, but we can't use either of those. Gracie, come here. My dog's getting into trouble. There's a third button that allows us to customize, and it looks like this. It's X to the Y. And just like last time, what we do is we enter first the X value, which is equal to the base, right? This number, X on the button. Then we hit the X to the Y key. Then we enter the Y button, or the Y value, which is the exponent. Okay? Again, this key is programmed to say, I'm taking the last number you gave me, that'll be the base, and then after you hit this button, the next number that you give me, that'll be the exponent. And you give it a happy tap on the equal sign, and voila, you will calculate an actual number of 26,734.88. And look how nicely that falls within our range. Hang on just a second. I've apprehended my dog and I'm dragging her back. Grace, I'm not even going to tell you what she was doing, but trust me, it was disgusting. Okay, so our actual number pans out beautifully given our estimate. Drop, sister. Sorry, I'm corralling a dog and comparing estimates to actuals at the same time. We accept this as a perfectly reasonable value. All right, the last part, which is part B of this, I'm going to flip. Flip my paper, I should say. Here's B. This time, we've got the same base, 9.26, except we want to do it to the minus 4.58. What on earth? Okay, well, we know that this is equal to 1 over 9.26 to the 4.58. And we came up with estimates for these. We would say it'll be between 10 to the 4th, 1 over 10 to the 4th, and 1 over 10 to the 5th, right? And this equals 1 over 10,000, and this equals 1 over 100,000. And because our calculator will give us decimals rather than fractions, sorry, we can write these two numbers as decimals. So our estimate is that this number will fall somewhere between 0.0, there's tens, hundreds, thousands, 10,000s, tens, hundreds, thousands, 10,000s, 100,000s, all right? So this is this number, this is this number. Your brain might resist trying to do that because it's been a while. That's pretty easy decimal calculations. Okay, beautiful. Now we are ready to do the actual calculation. We're going to use that X to the Y button again. So we will enter we will enter 9.26, then we'll hit this button, then we'll hit 4.58, then we'll make it a minus using that plus minus button, and then we'll hit equals, and the number that we get for our actual is 3.74 times 10 to the 5th. All right, I mean, that's great news, but I'm trying to compare this, and nothing looks the same. Oh, I'm sorry, it's 10 to the minus 5. Okay, this is the answer the calculator gives me. So how do I compare these? Well, let's rewrite this as a decimal number, and then we can see if it fits in this range. So this will become, let's see, 5 times. 1, 2, 3, 4, 5. I'm gonna need 1, 2, 3, 4 zeros. 0.0000374. That's my number. Does that fit in this range? This is 4 zeros and a 1. This is 4 zeros and a 3. That means this number is bigger than this number, which makes it greater is the proper math word. It's greater than this number, so that means it is in this range. Oh. Actually, that's not what that means. That means our number is technically outside of our range, right? This number is outside of this range, but it's close. John didn't compare his. Isn't that interesting? But I'm calling this close enough. This is the right answer, by the way. So this is just proof that sometimes our estimates, we do the best we can, but sometimes our estimates are just rough enough that we do fall outside of the range we predict, but it's close enough that we say, okay, we're obviously not off by, a whole decimal point. We look pretty good, and this is the right answer. So as much as it is important to estimate before we calculate, we also have to make sure that we interpret fairly, okay? And the other thing, which I 100% recommend, is always run your numbers through a calculator at least twice to make sure that your calculation is the same. Don't just do it once and call it good. Run it through at least twice, if not 3 times, right? Especially if you're getting the wrong answer. Keep trying to make sure that it's not just a case of fumbling fingers, because that happens too. Okay. Enjoy these problems. Remember that if John's instructions in the homework say use a calculator to blah, 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 which is what he does here. Let me show you how it looks in the book. Use a calculator to simplify. Estimate first. First estimate the answer and then use a calculator to get a more exact answer. Okay, so he will tell you when you need the calculator and you don't have to guess. I hope you enjoyed this lesson. I know I did. Thank you. Goodbye.